There's nothing more frustrating than trying to move around a heavy piece of shop equipment where the wheel is broken or has a flat spot. This cast iron jointer is missing a wheel. This part already broke once, and the only thing I can find is a bunch of OEM replacements or a bunch of used parts coming off of old equipment. So it's time to fix it and fix it right. I'm going to print this out of onyx with carbon fiber reinforcement on a Markforged printer. I grabbed a few dimensions, and this is probably the easiest 3D model I've ever had to make, but it highlights a really interesting feature of 3D printing with sparse fill. Notice these relief cuts are made to reduce weight and make it easier to manufacture in an injection mold. But does that type of design help or hurt the cost when you're talking about additive? So I'm going to try both designs and compare. So side by side with the default settings, the part with relief cuts is a little bit lighter and cheaper, but this is probably going to need to be a little bit stronger. So let's beef up these designs. I'm going to max out the recommended sparse fill density and then beef up the wall and floor thicknesses. And still the parts don't differ by too much. Now I'm definitely wanting to make this as strong as I can, so I'm going to add some reinforcement, in this case carbon fiber. And we're going to go to the internal view, which is where you can really start to see how these designs differ. The thin part is going to act like a disc carrying the load, and then it has a cantilevered lip on both sides that's basically unsupported by the fiber. The solid wheel is basically two discs that transfer the load directly down to the strongest parts of the pin there along the edges and away from the middle. Structurally, I like the solid wheel design a little bit more than the hollow one. And if I add a similar number of reinforcement layers to both of them, they still don't differ that much in cost. And if you look at their print time, it's almost identical. Now this is a really simple example, but it does really illustrate how design for additive manufacturing and design for regular manufacturing have different constraints. The 3D model for an additive part, it can be much, much simpler and less time to make than a part that you would normally make for something like an injection molded process. There are plenty of other considerations to keep in mind, but one of the big ones is removing material from the volume does not necessarily reduce the mess on an additive part. I started this project in the morning, and with a print time of under 7 hours, I was able to get it done and install it before the end of the day. I printed another one and stopped it so you could see the interior shape of the sparse fill as well as the thickness of these walls. This thing is extremely tough. It's like a hockey puck. And I got it installed and it had absolutely no problems right out of the gate. In fact, as I look at these other wheels, I can see that they're getting close to failing. So we'll definitely be keeping an eye on those. In a Markforged enabled shop, you're not beholden to whatever is on eBay or whatever the OEM has decided is what's going to work for your design. You have the power to build whatever you need, solve your problems, and get on to more important things. Let me know in the comments if you've got any ideas for what we can do next here in our shop using our Markforged printer.